All right, so get this. You're telling me quantum computers are shrinking down to like practically nothing.
Yeah. You're talking 1,000 times smaller.
Wow.
Okay.
And you sent over this article about it, and it's not science fiction anymore.
No, it's really fascinating, the impact that this miniaturization could have.
Yes.
I mean, it's going to change everything. Faster drug discoveries, understanding climate change better, even things we haven't even imagined yet.
So the article, it says that a lot of quantum computers right now use photons, particles of light,
Right.
as their building blocks.
Mhm.
And these photons need to be linked or entangled
Yeah,
to do their quantum thing.
exactly.
And so far, scientists have been using thick crystals and a bunch of equipment to make these entangled photons.
Yeah, they take up a lot of space.
So much space.
Yeah, that's been one of the biggest problems,
Yeah.
like trying to build a supercomputer in a closet.
Yeah.
But this article highlights a major breakthrough
Okay.
using a new material called niobium oxide, dichloride.
Niobium oxide what?
Dichloride.
Okay. What is that?
Well, the key is that it's incredibly thin, like 80 times thinner than a human hair.
80 times thinner than a hair.
Yeah,
That's like impossibly thin.
almost impossible to picture.
Yeah.
But they managed to create these entangled photons
Wow.
with this super thin material.
Okay.
And, get this, without all that bulky equipment they needed before.
So they figured it out. Like how?
Well, you see, the old methods, they relied on stacking these thick crystals to manipulate the photons,
Mm-hmm.
which really wasn't very efficient.
Yeah.
But with this new material being so thin, it's like they found a shortcut.
Oh.
The photons, they stay in sync as they travel through the material.
Okay.
You don't need all that extra equipment.
To keep them linked.
Yeah, exactly.
So it's like a tiny superhighway. But for photons,
You got it.
but have scientists tried this before to shrink these components?
They have, yeah.
Yeah. And what happened?
Well, they ran into a roadblock.
Okay.
Because as you make materials thinner, they tend to produce fewer photons, which makes them, not so good for computing.
Useless.
Yeah, basically.
So this new method, is that what they figured out?
Seems like it.
Like they cracked the code?
Yeah, they found that sweet spot, thin enough to be practical,
Mm-hmm.
but still efficient.
In producing these entangled photons.
Exactly.
Okay, so they shrunk it down.
Yeah.
But did they sacrifice power?
Well, that's where it gets interesting.
Okay.
Quantum computers rely on these entangled photons to do calculations way faster than regular computers
Mm-hmm.
because they can be in this like on and off state at the same time.
Wait. I remember reading about that. It's called
Superposition.
superposition.
Yeah.
But that's always sounded like kind of science fiction-y to me.
Yeah, well, imagine a coin spinning in the air. It's not heads or tails.
Okay.
It's both at the same time until it lands.
Yeah.
That's kind of what's happening with these photons.
Okay.
They're in this blurry state of being both 0 and 1
At the same time.
simultaneously. And that's what gives quantum computers their incredible processing power.
So instead of flipping a coin, they're flipping like millions of these quantum coins all at once.
Yeah, billions even. You got it.
Okay, but it's got to be a catch.
Well, this being in two states at once thing, it only works if the photons are produced in pairs
Okay.
with one photon entangled to the other.
Like best friends.
Yeah, exactly. Like
Yeah.
they need to be vibrating in sync.
Okay.
Almost like synchronized swimmers.
Okay. I'm with you. But the article mentioned that the initial photon pairs,
Yeah.
they weren't entangled. So
Yeah.
how'd they fix that?
Well, they had to borrow a technique
Okay.
from a traditional method used with thicker crystals,
Mm-hmm.
where they would stack two flakes and position them in a very specific way to create entangled photons.
Oh.
But adapting that method for a material this thin, that was a real challenge.
So instead of like a stack of pancakes,
Yeah,
they're working with something more like a crepe.
that's a great analogy.
Super thin.
Yeah, and because it's so thin, the photons, they don't get out of sync
Oh,
as
go
they
ahead.
travel. So
But-
they don't
yeah.
need that extra equipment.
To keep them entangled.
Exactly.
That's pretty brilliant.
It's a brilliant workaround.
Okay, but why photons? Are there other like particles that they could be using?
There are,
Right.
but photons have a distinct advantage.
Which is?
They can be produced and entangled at room temperature,
Right.
which makes them much easier to work with.
Okay.
Other particles, like electrons, they need extremely low temperatures to show off their quantum properties,
Oh, wow.
which is, complex and expensive.
So using photons is like the easy mode of quantum computing.
In a way, yes.
Okay.
It makes everything much simpler and more practical.
Yeah.
And that's why this discovery of using niobium oxide dichloride is so significant.
Okay.
It brings us closer to a world where quantum computers are more accessible.
Yeah.
and can be integrated into our lives in ways we haven't even thought of.
It's like they're laying the groundwork for a quantum revolution.
Precisely.
Okay.
And the fact that they're already looking at ways to improve it, well, that speaks volumes about how quickly this field is advancing.
So before we start picturing quantum computers in our pockets, can you remind me what kind of problems are quantum computers expected to solve?
Well, think of areas where we need to crunch enormous amounts of data and make complex calculations.
Okay, like what? Give me some specifics.
Like climate science.
All right.
We need to analyze massive data sets
Yeah.
to understand and predict weather patterns, which is, crucial for addressing climate change or drug discovery, where simulating complex molecular interactions to develop new medications could be significantly accelerated.
The article mentioned that calculations that would take supercomputers millions of years could be done in minutes by quantum computers.
It's hard to even grasp that kind of speed.
Yeah.
But it's not just about speed. It's about the potential to solve problems that are currently beyond our reach.
Okay, so it's more than just doing things faster.
Exactly.
The article also said something about them being able to do, multiple calculations at the same time, unlike our regular computers.
Right. Our regular computers, they do things one step at a time.
Yeah.
Quantum computers, not so much.
That's because of these magical qubits.
The quantum bits,
Can be in multiple states at once.
Exactly.
Unlike those classical bits, which can only be 0 or 1.
Right.
So it's like having millions of processors all working at the same time.
That's a good way to think about it.
No wonder they're so powerful.
Yeah, exactly.
But why aren't we all using them?
Well, there have been challenges.
Like what?
Finding materials that are thin enough for miniaturization, but can still produce these entangled photons efficiently. Remember, as materials get thinner, they tend to produce photons at a much lower rate, which makes them impractical.
For computing.
Exactly.
So this new material, it's like the Holy Grail.
It's a huge step in the right direction. Thin and efficient.
Niobium oxide dichloride has this unique ability to produce these pairs of photons efficiently, despite its thinness.
So, problem solved.
Well, not quite.
Oh, what else?
They still had to figure out how to make those photons dance in sync, remember?
Entangled.
And that's where the ingenuity of these researchers really shines.
Okay.
They took inspiration from a traditional method used with those thicker crystals and found a way to adapt it.
To this incredibly thin material.
Exactly.
Okay, so that's where that stacking technique comes in. They had to reinvent the wheel.
Yeah, but on a microscopic scale?
Microscopic scale.
Well, and because those flakes are so incredibly thin, the photons stay in sync as they zoom through the material without needing any extra equipment.
To keep them entangled.
Right.
Wow.
Pretty ingenious, wouldn't you say?
Absolutely. So they miniaturized this whole entanglement process without sacrificing efficiency.
That's right.
Game changer. Yeah, it's a game changer.
But they're not stopping there.
Oh, absolutely not.
The article said they're working on even more improvements.
They're exploring the idea of etching tiny patterns onto the material.
Okay.
Like microscopic grooves.
Okay.
To see if they can boost the production of entangled photons even further.
So, they're fine-tuning the material at a microscopic level?
Exactly.
Yeah.
It's like they're coaxing those entangled photons into existence with each tiny groove. And they're also looking at whether stacking the niobium oxide dichloride with other materials could further boost photon production. So it's not just about the material itself.
Right.
It's also about how it interacts with what's around it.
So they're building a whole ecosystem.
Yeah, an ecosystem for these entangled photons to thrive in.
It's pretty remarkable that all this is happening right now.
It is.
This isn't some, distant future.
No, this is happening as we speak. Yeah. It's a truly exciting time.
To be following this field?
Absolutely. Every new discovery just opens up a dozen more possibilities.
It makes you wonder what the world will look like when quantum computers are as common as our smartphones.
Oh, it's a tantalizing thought, isn't it?
Yeah.
But before we get lost in the possibilities of the future, let's take a moment to appreciate the ingenuity and dedication
absolutely.
Of the researchers behind this breakthrough.
They're like pioneers of a new technological era.
They are.
All right, let's take a quick pause, and when we come back,
okay,
we'll explore what these miniaturized quantum components could mean for your life.
Sounds good.
Stay tuned.
You know what's really cool is how they're combining cutting-edge ideas with classic techniques.
Like old-school wisdom meets futuristic tech.
That's a great way to put it.
So the article mentioned that they're already looking for ways to improve this, even more.
Oh, absolutely. They're exploring some really interesting possibilities.
Like what?
For example, they're experimenting with adding those tiny patterns, like almost like grooves, onto the surface of the niobium oxide dichloride flakes. And the idea is that these patterns could actually help produce even more of those entangled photon pairs.
So they're fine-tuning the material at a microscopic level.
Exactly.
Oh, wait.
It's like they're coaxing those entangled photons into existence.
With each tiny groove.
With each tiny groove. And they're also looking at whether stacking the niobium oxide dichloride with other materials could further boost photon production. So it's not just about the material itself.
It's about how it interacts.
It's also about how it interacts with what's around it.
They're building a whole ecosystem.
Yeah, an ecosystem for these entangled photons to thrive in.
Okay. But we've talked about faster drug discovery, climate modeling.
Yeah.
But what other potential applications are there?
Well, the possibilities are practically endless.
Endless, okay. Like
imagine a world with personalized medicine tailored to your specific genetic makeup, or super accurate climate models that can predict and mitigate the effects of climate change with incredible precision.
Wow, okay. Those are some pretty huge applications.
They are.
What about material science?
Yeah, materials science.
Could these tiny quantum computers help create new and innovative materials?
Absolutely. Think about lighter yet stronger materials for building everything from airplanes and cars to bridges and skyscrapers, making them more efficient, more sustainable.
Yeah.
Or imagine materials that can conduct electricity with practically no resistance.
Okay.
Leading to a revolution in energy efficiency.
So it's like this technology could usher in a new era of scientific discovery and innovation.
Yeah.
And what about AI? Could quantum computers lead to like even more advanced and sophisticated AI systems?
Without a doubt. Quantum computing could supercharge AI development, leading to more powerful algorithms capable of solving problems that are currently beyond our grasp. Imagine AI systems that can analyze massive data sets to uncover hidden patterns and insights, leading to breakthroughs in fields like medical diagnosis, financial modeling, and even creative endeavors.
It's like we're unlocking like a whole new level of human potential with this technology.
It's a truly exciting prospect.
Yeah, but we're still in the early stages.
We are.
So what are some of the hurdles researchers still need to clear? Like what's standing between us and this quantum-powered future?
Well, one of the biggest challenges is scalability.
Okay.
Right now, quantum computers are still relatively small and quite expensive to build and maintain. To make them truly accessible and widespread, we need to find ways to make them larger and more cost-effective.
It's like we built the first prototype of a revolutionary machine.
Yeah.
But we still need to figure out how to mass produce it.
Exactly.
Okay, so there's that.
Yeah, and we also need to develop the software and algorithms. That will allow us to truly harness the power of these quantum computers. It's not just about the hardware, it's about creating the tools that will unlock its full potential.
So it's like a two-pronged challenge.
It is.
We need the hardware
and the software
to advance and the software to keep pace. But the article also mentioned the team behind this breakthrough involved experts from all these different disciplines.
Absolutely. The team included experts in electrical and electronic engineering, physics, material science, and more.
So they assembled like a dream team of scientific minds, each bringing their unique expertise.
It really shows how interdisciplinary collaboration is driving innovation in this field.
So they're pooling their knowledge and skills.
Yeah.
And they were able to achieve something pretty remarkable.
They did.
You know, we talked about those entangled photons being like two synchronized clocks that always stay in sync.
Right, no matter how far apart they are.
Yeah, it's mind-boggling. But it has some pretty incredible implications for the future of communication.
It does, doesn't it?
So how could entangled photons, like, revolutionize communication?
Well, imagine a world where information can be transmitted instantaneously.
Okay.
Regardless of distance. It would be like having a real-time conversation with someone on the other side of the world. Yeah. Or even on another planet with absolutely no lag or delay.
That would transform everything.
It would.
From global communication networks to space exploration.
It would transform it all.
But it's not just about speed.
No, you're right. There's also the potential for incredibly secure communication channels.
Okay, so like, how would that work?
Well, remember how we talked about those entangled photons being linked?
Yeah.
Well, if anyone tries to intercept or eavesdrop on a message sent using entangled photons, it would disrupt the entanglement, immediately alerting both the sender and receiver.
The intrusion.
Exactly.
So it's like a built-in security system.
Yeah, it's virtually impossible to hack.
All thanks to this quantum entanglement.
Exactly. It's mind-blowing to think that something so tiny, a pair of entangled photons, could have such a profound impact on the way we connect and communicate.
So as we wrap up this part of our deep dive, I want to leave you with a thought-provoking question.
I'm all ears.
If this breakthrough in miniaturizing quantum components is just the beginning, what other groundbreaking discoveries await us in the realm of quantum technology?
That's a great question, one that researchers around the world are working tirelessly to answer. The possibilities are truly boundless, and it's an incredibly exciting time to be witnessing this technological revolution unfold.
And we're not just passive observers.
No, we're not.
We get to be a part of this unfolding story.
We do.
Every time we learn about these advancements, we're expanding our understanding of the world and our place in it.
Absolutely. It's a privilege to be living in an era of such rapid scientific progress. And as we continue our deep dive, I'm eager to explore what these discoveries mean for you, our listener.
Let's dive back in after a short break. So we've covered a lot about shrinking quantum components, the science behind them. But, what does it all mean for the average person?
Right. Well, it's important to remember that quantum computing, it's still kind of in its early stages, but we can kind of already see how it might impact our lives.
Yeah, the article gave some examples like faster drug discovery and more accurate climate models.
Right.
Can you expand on those a little bit?
Sure. So faster drug discovery, imagine new medications being developed.
Yeah.
Much, much faster.
Yeah.
This means that life-saving drugs could be available sooner, impacting, countless lives.
That's amazing.
And for climate change, having those more accurate models, it's a game changer. We could predict and prepare for the effects of climate change with much greater precision.
So better mitigation strategies.
Exactly.
And I remember the article also talked about how this tech could revolutionize material science.
Oh.
Can you give me an example of that?
Sure. Think about materials that are lighter but also stronger than anything we have right now. Imagine using those materials to build everything, from airplanes to cars, bridges, skyscrapers, making them more efficient.
And more sustainable.
More sustainable, exactly. Or materials that can conduct electricity with, almost no resistance.
Okay.
That would lead to a revolution in energy efficiency.
Yeah, so we're talking a materials revolution.
Yeah, a materials revolution.
Right.
And then there's AI.
Yeah, AI. What could this mean for AI?
Well, quantum computers have the potential to, really boost AI development. We could see AI systems that can solve super complex problems, leading to breakthroughs in fields like personalized medicine, where treatments could be tailored to your unique genetic makeup. Imagine financial models that can predict market trends really accurately, or even AI-powered tools that help with artistic creation.
So this is really huge.
Yeah, it is. The potential applications are almost overwhelming.
But to be realistic, what challenges are still there? What's standing in the way of this quantum-powered future?
Right. One of the biggest challenges is scalability. Building large-scale quantum computers that are stable and reliable is still a big problem. They are pretty small right now and super expensive to build and maintain. So we need to find a way to make them larger and more affordable.
So it's kind of we have this powerful engine, but we need a bigger car.
That's a great way to put it.
To harness that power.
Yeah, a bigger and more efficient vehicle.
And we also need the software, right?
We do. We need to develop the software and the algorithms that can actually take advantage of these quantum computers.
It's a two-pronged challenge.
Yeah, hardware and software.
But what about the ethical implications? As this tech gets more powerful, should we be worried?
Well, that's an important question.
Yeah.
With any powerful tech, there are always ethical things to think about.
Yeah.
For example, making sure that quantum computing resources are used responsibly and that everyone has access to them.
Yeah.
That'll be important to prevent misuse or, unintended consequences.
Yeah.
It's a conversation we need to have as the science advances.
So we need to be careful and thoughtful as we enter this new era of quantum computing.
Yeah, we need to find the right balance. Fostering innovation, but also being responsible.
It's a good reminder that progress isn't just about the technology.
Right.
It's also about making good decisions.
Exactly.
Okay, so to wrap up this deep dive into the world of shrinking quantum components, what's the one thing our listeners should remember?
I think the big takeaway is that we are living in a really exciting time. The possibilities are pretty much endless.
Yeah.
And even though there are challenges, the potential benefits are huge.
So quantum computing, it's a field that's full of wonder and discovery.
Yeah, it's a story that's still being written.
And we're all part of it.
We are. So stay curious, keep learning.
And who knows, maybe you'll be the one to make the next big discovery in this field.
Maybe you will.
And that's what we love about the Deep Dive. It's all about exploring these new ideas and bringing you along with us.
That's right.
So thanks for joining us for this deep dive, and we'll see you next time.